In this video, I'm going to discuss high dynamic range images, both creating and using high dynamic range images such as HDR files or EXR files. Those are the two main types of high dynamic range images that we use in computer graphics these days. EXRs tend to have a little more capabilities than HDRs, but they're really fairly similar in that they're floating point formats and can store a lot of data. To get started, what I've done is I've just created a super basic sphere here on it's actually sitting on a ground plane. You can't see it here because it's frozen in the viewport, but it's there. And for lighting, I have a skylight set to currently it's the default setting of this particular color. And if I just give this a render, you'll see it's just very basic, nothing really attractive about this. And it is using Final Gather for some indirect illumination in the scene. That's how the skylight works. It has to work with Final Gather in order to produce light. The reason that I'm using a skylight in the scene is that in order to have the HDR emit light in the scene, I need to pass it through a skylight, either via this map or using the scene environment. So a lot of times the first thing that people want to do, their first CG image, is often something reflective, ray trace, kind of maybe even chrome. So what I want to do is change this material that's on the sphere from a standard material over to an A&D material. Use it in the environment map so that everything in the scene will reflect the HDR image. So I'm just going to assign a bitmap and then go and select where the bitmap is. And I have an HDR folder. But also 3D Studio Max comes with some HDR maps, and you'll find those in the HDR folder of your install. And if you just click on the ones that come with 3D Studio Max, you'll note that there's two versions. There's a small resolution and a larger resolution. For the environment, what I'm going to do is use a larger resolution. The reason that there are two different versions here, if I just click on one of these, you'll see on the large version you see a little more detail here, like so, whereas on the small version, and you can see that it's a lot smaller, it's blurred. The reason that you create something like this is that the small version is used for lighting. It's obviously more diffused color here. You don't have all those sharp reflections, and the reason for that you would want to do that is that will make it easier for your indirect illumination to provide a clean result, a noise-free result. Whereas if you're using a high resolution HDR image, you can see all the detail that you would get out of this, and if you're using, say, mental ray like I am here, the Final Gather solution may be a little bit noisy, so you'll have to increase the samples to clear a scene if you're using this for your lighting. Whereas if you're using the smaller version, you can use fewer samples, fewer Final Gather samples to get a clean result. The downside to using this is that you won't get really sharp shadows, a lot of shadow detail out of this because it's a smaller, blurrier object, map here. But on the same hand, if you're using Final Gather, even if you use a high resolution image with a lot of data in that HDR image, you're still not going to get crisp area shadows when using Final Gather. The newer versions of Mental Ray have importance and irradiance particles, and that, if you use that, that's about the only way in Mental Ray and 3D Studio Max that you'll get nice shadows if you use HDR for illumination. But for this example, what I'm going to do is come in and use, in the environment, I'm using this medium resolution HDR image here, and I'll just load this in. Now I need to set the mapping coordinates of the HDR image. So I just drag this over to the material editor as an instance copy, and it defaults to environment screen mapping, and I want spherical mapping. And it's always a pretty good idea to decrease this blur amount whenever you're using mapping, because you can get a little more detail out of this. See if it shows this in the preview here. If you change this to 0.1, which is the lowest value you can go to, it doesn't really show it in this update, but you can see it, kind of see it happen here in the material editor itself. I hope it shows up on the video, but if you set this to the lowest amount, you can't set it to 0 because that it won't let you. You can just go to 0.01, but setting that blur to a low value will give you just a little bit more detail. Okay, and then give this a render. So now, instead of having that black environment or black reflection, what you see is this room, and the HDR image really shines here, because what you'll get is if I sample, you can see the pixel values here. The real pixel value here is 0.15, whereas if I go up to this rendered HDR image and move over one of the lights, you can see it actually goes far beyond 1.0 for a pixel value, pixel strength. So you get a lot of range of information in here. Now, to get this value to go beyond 1, I have to be rendering in a 32-bit frame buffer, and you set that up here in your render settings for a frame buffer type. You can use either a 16-bit or a 32-bit. If I use the 16-bit and render this, all of these values will be clamped at 1.0. No pixel will be stronger than 1.0. So I'm going to use the 32-bit frame buffer to exceed a pixel value of 1.0. Now, the usefulness of that is that, for example, if you wanted, one good thing is if you wanted to use the glare shader. Let me just enable this and drag it over to the material editor so I can modify the settings. I'm going to increase the quality setting and enable streaks and make the streaks rather strong, and render this again. It's calculating the streaks, and there you can see it apply. Now, that glare shader, what it's going to do is apply the glare to the brightest areas of the scene here. Now, if all of these areas were clamped at 1.0, then the glare would be evenly applied throughout the scene. Using the 32-bit frame buffer and this HDR image, the glare is only applied to the very brightest highlights in the scene that exceed that pixel value of 1.0. Let me just go and disable that again. Now, the scene here, as you can tell, it's kind of, the lighting is flat. And you see this flat reflection of this grid, this floor grid that I've set up, and that's because I'm not using the HDR for illumination at this point. I'm just using it as an environment map for reflections. In order to use it for illumination, I can just simply go to the skylight and tell it to use the scene environment map. And so now it's going to illuminate the scene using this same image or HDR file that I'm using for the environment map. And again, in order to get illumination, I have to have Final Gather enabled. That's the only way. If you're using Mental Ray, you have to use Final Gather in order to get light from the skylight. So now if I render this, the illumination will come from that HDR image. So now the scene is illuminated from that HDR image. Now, if I wanted to change the lighting of the scene, I can easily do so by switching to a different HDR image. So now I'm going to go from an interior to an exterior render. One quick note about these HDR images when you load them in to your scenes. As I load these in, generally speaking, these are floating point format images and should be loaded in as Gamma 1.0 or linear. So if you're using a customized gamma setting, such as if you had a bitmap input gamma of 2.2 here, then when you load an image in, it will be loaded as gamma 2.2, and you generally don't want that for an HDR or an EXR type file. You want to load those in linear format, such as i.e. gamma 1.0. Now, that's not to say that every HDR out there is linear and gamma 1.0. I have some that are actually gamma 2.2. I'll show you the difference here in just a second, but if you go in and load these, you can use the image's own gamma to override your gamma settings here. You can use the system default, which would load it in my case, at gamma 1.0 because I have a bitmap input gamma setting of 1.0. If you had a bitmap input gamma of 2.2, okay, you notice how the image is kind of washed out. It doesn't have a lot of contrast in it. Let me just make a copy of this, and I'll reload this HDR using gamma 2.2. Okay, it looks like a glitch here has happened because, as you can tell, the lighting has changed, but the reflection has not. I was expecting this to become more, have more contrast and look a bit more realistic, like you would see from a photograph. But by changing that gamma to 2.2, the lighting changed, but the actual reflection data did not. So what I'll do instead is patch this through a gamma and gain utility shader. Let me just pull up the material editor here, and I'll just scroll down to the utility gamma and gain shader, and I'm going to tell it to keep this old map as a sub map. And what I'll do, I'll just reload this using the image's own gamma, which is these come in at gamma 1.0, these linear images. So what I need to do is adjust the gamma now. If I set this to 1.0, that's going to be the same render as this. You can see that the result's the same as our first test. Now if I go in and I change this gamma setting to 2.2, so as you can see, the difference is rather dramatic between these two. This is the incorrectly loaded gamma HDR, and this is the correct one for this particular HDR. And as you can see, I get more information, more shadow details, a lot better result when it's loaded in with the correct gamma than when you use an incorrect gamma. You'll get this washed out result. So 0.0 for this particular HDR, because this is a correct linear HDR. Okay, so now you're not really seeing much in the way of shadow detail here. There's a couple of things that we can do to improve that. One is in the final gather settings, you have this noise filtering option. You can set that to none, and what that's going to do is this noise filtering actually, well, it filters out some of the light in the scene that may cause overbright areas. So if you set that to none, then you have no filtering on the light itself, and you get a little more illumination in the scene. Hopefully, to show that, what I can do is put this in the RAM player. Move this off screen and give this a render just with that one change. Where I set the filtering to none, and we'll see a difference. And it looks like and I will need to change the gamma setting here to 1.0, and go ahead and load in the HDR image. Again, I'm using the small blurred version for the lighting. And I want to set the mapping environments to the same as the other one. I need environment mapping with spherical coordinates. I'm not going to worry about the blur on this one because it's already a blurred image, so I don't need to decrease that. And so now what will happen is I'm using the high resolution image, or the high resolution HDR, for my environment map, and I'm using a local low-res blurred version for the illumination. Okay, so that's the basics on how to load the HDR images in, and kind of a real simple overview of using a higher resolution for your reflection map and a lower resolution blurred copy for your illumination. Now let's just go ahead and apply this to a more typical scenario, because obviously this little sphere test isn't representative of a real world scene that you may want to use HDR illumination on. So I'll just go load a scene, and I'll use this one. Okay, so I have this architectural scene, and I'm going to illuminate this with an HDR image. Let me just back out of the scene. As you can see, there's no lights in the scene yet, so just like in the previous test, I'm just going to go and add a skylight here, and it's under the standard lights when you create a light. Doesn't matter where you put this in the scene, by the way. It's not a directional light source. You don't have to rotate this in any specific direction. Just drop it in the scene. And of course I need to make sure that I have Final Gather enabled, and I'm just going to use a medium preset. I'm going to set the noise filtering to none again, so that I get the most light that I can, most lighting data that I can out of the HDR image that I'll be using. Now, just like before, I want to use the HDR image for the environment as well as the illumination. So let me just bring up the environment map here, environment options, and my material editor. And again, I'm going to patch everything through a utility gamma and gain shader. Different scene, what I could do, or different lighting setup, is just change the HDR. Maybe something like this. That's definitely going to give me more of a blue light source. I kind of like that one. It gives kind of an early morning feel to the image. You can see the light seems to be streaming in from behind the camera. And if I wanted to change that, I could just rotate this offset, and you can see how that's rotating in viewport. I can rotate that around and change where the lighting's coming from in the scene. Or something else that I personally like to do is use this HDR lighting kind of as fill light, and still add a traditional light for the sunlight. So for example, if I go in and add, I'm just going to add a mental ray area light here, maybe an area spot, and I know the sun is coming from this general direction, and I just know that because of the light direction here. You can see how it's kind of a warm bright color here on this facing wall, and cool on the top and away from that particular area. And the sun is going to be pretty low on the horizon, so let me just move this up just a little, maybe like so, and give it a warm color. Maybe something like that. And what I probably also want to do is, since the sun is pretty low on the horizon, I want to increase the area light size to kind of blow out these shadows so they're not super sharp. I want them fairly diffused. Okay, that looks pretty good. I think I'll render a higher resolution of this one now. I'm just going to leave that at the medium Final Gather preset. And I'll just increase my image precision to get rid of the jagged edges, and increase the image resolution like so. And I think I'm ready to render this one. Now, as you look at this final render, you may notice that the environment map is rather pixelated looking, and the reason for that is because it's not a very high resolution image. Even though it's, I believe, 2,000 pixels in size, that's really not what I would call high resolution these days. These days, it's actually more common to have an HDR or an environment map in the range of 6 to 8,000, even 10,000 and 14,000 pixels is not out of the question. Of course, once you start going up to that resolution, memory handling becomes an issue, and you may want to make sure that you're using a 64-bit operating system. Just so that you have more RAM allocation and memory allocation to handle those very large files like that. But what happens is at this lower resolution, at this 2,000 pixels, it stretches that all the way around the scene. And so when I render this out at such a fairly large resolution as 1200, which isn't massive by any stretch of the imagination, but at 1200 pixels, with that HDR environment being only 2,000 pixels in width, and it's stretched all the way around, and we're just seeing a small section of it. That's why it become pixelated like that. So just remember that if you see that, you may want to make sure that you're using a higher resolution environment map. Next, I want to show you how you can actually create your own HDR images from 3D Studio Max, and then use that in something like a studio environment scene. So I'll just reset 3D Studio Max here. Let me just go ahead and save this as a copy. So now I'll just reset 3D Studio Max. So what I want to do here is I want to create my own HDR image for use in a scene, and what it's going to be is kind of I'm just going to go through and set up some light cards, and light cards will be some self-illuminated planes, just something to give me some reflection, but it will also generate light once I save this as an HDR image and use it in a scene with Final Gather, like what I've done in the previous portion of the video. So to do that, what I'm going to do is just create some spline shapes here in the viewport. And let me just center these up. And this will be one light card. And what I'm going to do is just convert this to an editable poly. Maybe move it out 2,500 inches or so. And I should probably make this larger, because for the end product, it's going to be a spherical map. So I'm going to increase the size of this quite a bit. Maybe like so. And I'm not moving it an even amount here, just because I know there's going to be a ground plane on the scene that I'm rendering. So I don't care. Again, this is going to be a 360-degree spherical image that I'll create. And I'm not really concerned about this light card going down under the object that I'm going to be illuminating. So I'm just putting it down just a little bit here. I'm more concerned about the vertical height. Something like so. Something like 650. And apply that to this other object. So what I need to do now is add a camera to my scene. So I'm just going to add a free camera here, and I'm going to position it at 0, 0, 0 world coordinates. The next couple of steps would be I need to disable Final Gather, because I'm not worried about illuminating anything in this scene. I just want these cards to be glowing, so I don't have to calculate Final Gather. I do want to increase the maximum samples to the next level up from the basic setting here, just 1 in 16, just so that I don't have too many jagged edges on these. And then to make a panoramic image, I'm going to use a lens shader, this camera lens shader called Wraparound Loom. just double click that, and there's nothing to change on this. So a lot of these you drag over to the material editor. If you drag this one over, there's actually nothing in it to no parameters to change. So, and what that does is just create a wraparound effect. Let me switch to my camera view and give this a quick render, and you'll see it's basically creating a panoramic image. So I just need to change my output size here to something more conducive to a panoramic image. Let's say using an image aspect ratio of 2.0, for example. The other important aspect of this is that you need to be working in a 32-bit frame buffer so that the values will be a floating point value here. For example, when I right click, you'll see that the real pixels extend beyond 1.0 in brightness. So I did go back and increase the intensity of these materials here. I've got this one to 2500 and this one to 1200, just because when I rendered that last preview the values weren't as high as what I want them to be. Okay, so now I may actually want to create another light source, and let's move this one, rotate it as an instance, and put it somewhere like this. See what that looks like. Okay. And for the final render, that's basically it. For the final render, what I'm going to do is set up a fairly high resolution, maybe 3000 by 1500 pixels, because it'll go through this fairly quickly since there's no indirect illumination or anything like that. Of course, you could do something a little fancier than this. You could put some gradient ramps in to give kind of a soft light effect. You could add the like the glare camera shader to give a soft light effect, or change the shapes. All kinds of options here. This is just a quick and dirty example, if you will. So I'm going to render this out, and then I'll save it. Again, it's in 32-bit format. I'll save this as an HDR image, and then take this HDR into another scene and illuminate and use it for reflections as well. Alright, so that's done. What I need to do before I save this is just check to get a bearing on what Kelvin values I use here, because it'll help me once I know this to balance the look that I get from this HDR once I get into the new scene. So I know that some of these light cards are 3200 Kelvin and some are 4600 Kelvin. So I'm just going to save this file as 32 and 46. Let me say 32K and 46K. And I'm going to save it as a HDR. And I'm just going to save this using the non-clamped real pixel color information. And I'll just close that and load up another scene. Okay, so now I'll try to illuminate this scene using that HDR that I just made. So I'll go into the environment map and add that gamma utility gamma and gain shader. Drag it over to the material editor as an instance copy, and go and find the HDR image that I just made. And I'm going to load this in. Just a quick note, because I know I didn't mention this earlier. The best way to load in newer versions of 3D Studio Max, the best way to load in these HDRs is to use this real pixel 32-bit format and the default exposure. Since these things are floating point values, you don't necessarily want to load them in as 8-bit or 16-bit. You want 32-bit in order to get all the lighting data and information that you can out of these HDRs and EXRs that you're using. You don't really need to go in and set the black point or white point or worry about that. That's what this default exposure option does, so I don't need to define that. And of course set this up for spherical mapping. Okay, the next thing I need to do is set up a skylight in the scene, because I'm going to use this HDR to illuminate the scene. It's not enabled at this point. What I want to do now is just go and give this a test render to see what this HDR is going to look like. And so what you're seeing here is the reflections of that HDR that I just created. You notice the warm color. This isn't a gold material, by the way. It's just a reflective material, but since there's no light in the scene, the only thing that you're picking up is the reflections. And it's yellow for that reason. Where I set up the colors a while ago, what was it, 32 Kelvin, 32,000 and 46,000. So I can adjust the look of this by going into the exposure control. And at 6500 you're actually seeing that the more warm color, but if I set this for something in between 32 and 46, let's say 4000, then what'll happen is I'll have a little bit of a warm color from the 3200 light cards, and a little bit of a cool color from those 4600K cards. Likewise, if I set my exposure control to one of those values, it would make that value white. For example, if I set it to 3200, now the warm light colors here will actually be white, and this should turn more blue. And so that's fairly close. Just to have a little more contrast in color, I'm going to set that back to 4000. And now let's give this a try as far as illuminating the scene with this particular HDR. I'm just going to switch it to use the scene environment, and of course enable that skylight. But I also need to go back to this HDR. One thing that I failed to do was it's still loaded in as Gamma 2.2. Again, it was a linear file that I saved, HDR file, so I need to change that to Gamma 1.0. That's probably why that light source did not go solid white a while ago. So let me just go back and open up my exposure control, set that back to 3200, and see what I get. Yeah, that's better. So again, that gamma plays a big role. If you have that set up incorrectly, you can see how it influences your lights as well. So I'll just set that back to 4000. And it did not illuminate the scene because I have not enabled Final Gather. I've got this light source enabled, but I need to go and enable Final Gather now. That looks good. And so now you're seeing the illumination calculation from the HDR map that I made previously, as well as those reflections that you're seeing are coming from the HDR map. And when this gets done complete, when this render is complete, what I'll do is hide this back plate and zoom out so that we can see that HDR in the environment. All right, let me hide this back plate that I made and zoom out just a little bit. Maybe rotate around, and I'm just going to turn off I'll leave Final Gather on so that we can see some lighting here. Now you can see how large that ended up being, but that gives a nice reflection as well as some nice soft lighting in the scene. Now of course you could actually make light sources the same way. You could make large light planes or self-illuminating objects in your scene. I just wanted to show you a way that you could render out HDRs, because you can light a scene this way without actually having to add area lights to your scene, or maybe you wanted some strange shaped lights. You could make some umbrella type light fixtures and things like that in that HDR scene that you can't make maybe necessarily with actual light sources. So again, just wanted to show you a way that you could do that. And with that, I believe that will wrap up this discussion on HDRs and using those in your renders to illuminate the scenes as well as for reflections.